Very few are there. Still, so 4 students are there. Anyway, we will start. So as per the instructions of your HOD, he said today we have to go for revision because most of the people are not there. And for the last few classes, this is our 6th class, we are talking about various inference management systems. Today we will solve some problems on a natural direction system. So we know natural direction system is a system which accepts all symbols, whether it is and, or implication or bisection, it will accept all the symbols. And the important thing that natural direction system you need to understand is it will be going based on these 9 rules. So we'll see what exactly these rules, and we'll just solve some problems that I have taken some problems. Like I have 5 to 6 problems, 7 problems are there. We'll solve and just close because it is just a revision section that was instructed by the HOD. So a natural direction system is a system which will accept, it's a universal acceptor actually. It is an inference mechanism which will accept ors, ands, implication, bisection, and not is a universal acceptor, not it can be applied for any other, any inference mechanism. So all these operators are accepted, and we have set of rules, and we have seen these rules many times when we started this inference mechanism in last Saturday, and this is Saturday. So obviously for the last 5 to 6 classes we have been seeing these rules. Like you have an element called as P, we say that P is a fact. You can R any of the other facts so that the resultant value, like the fact, will not change. So if you have a P, you can add Q or you can add R, whatever it may be, but you have to do something called as Ring. So the resultant truth value will not change. So you have a statement called P, you have a statement called Q. You can combine both of them by using AND. If you have a statement which is called as true and you have other statement Q which is true, you can combine them by using AND. You can combine them. So the reverse is something like this. If you have P and Q, you can take either P or you can also take Q. So this is called as simplification, and you combine, we call it as conjunction. You add something like you have a P, you add, we call it as an addition. These are the names that you can just write when you are simply doing that. So the most important inference rule in many systems is you have P implies Q and P you can infer Q. Is very important. We call it as modus ponens. You have two statements like P to Q was there and negation of Q was there. The inference that you can get is negation of P. It is called as modus tollens. Many of the systems will accept modus ponens. So that is the reason modus ponens is very important, and it is explicit. This is what you have done in your discrete mathematics also. So you have P R Q and negation of P. You join both of them by using R, you will get Q. So this is associative property P to Q, Q to R, you will get Q, P to R. So these 7 rules are very important, and these 7 rules we call it as atomic rules. So we can apply all these rules to get the inferences in NDS, natural deduction system, and these two are hybrid rules. that these rules are a part of this 7. So obviously there is no need that you have to remember this constructive dilemma and destructive dilemma, because all these 8 and 9 are consequence of the 7. So whenever people ask about NDS, you write about all the symbols are accepted, at the same time the 7 rules are used to infer something, and just straight away I am going to these problems now. So just I will just verify how many people are there. 21 are there. Okay. So this problems, some problems again I am taking from textbook, some problems I am taking from your external examination. Some of them already done in the class. Since it is just a class which is more pertaining to revision, so that is the reason I have taken these simple problems, which many times they are giving it for 8 marks. So whenever like 4 statements are given and you need to prove this inference, this is an inference that sometimes is valid, sometimes may not be valid. These are your facts that are given. So what is your challenge is you need to use these rules to get these values. So where exactly we can start? Like you have 3 statements with one operator with 2 operands. So obviously I can start with negation of R. So if I combine these 2 statements, can somebody unmute and just tell me what can be the outcome of this? Like if you combine QBR and negation of R, what can be the outcome? See, straight away you can combine with R. See, you will get something called as Q, R, R. You can write an R here and negation of R. So what is that you get here from is only just a Q you will get. So from these 2 statements I got a Q. So then how can I proceed? See, arbitrarily you have to start. See, I will do like this. This is a statement and there is a Q here. When we join these two, what is the output? I have a Q here, I have this here. So what can be the outcome here? See, again you can write R here, negation of P, R, negation of Q, and you have a Q here, you can write R here and you can write. So what will happen? This goes and what will remain is negation of P will be there. So if I combine this part and this part, so what is that I will get is S, R, P, V, negation of P. So for these two will go and you have something called as inference S that is valid. This problem was done in the class. Since it is a revision and most of the time this question was asked many times in your external exam, that again I am doing the same thing. So you can see a second example which is very simple than the earlier one, because this 4 statements are given and 2 statements are with single variables. You have a Q here, you can start here, or you can R here, you can start here. So if you remember the class, if I combine these two, because R is common here, can somebody unmute yourself and tell me what exactly the outcome here? What can be the outcome here? Like, just I'm doing this. You have a R here. You combine this with these two statements. What can be the outcome here? So you need to active in the class. If you combine this, what is that you'll get is a value called as P. So if you combine both of them, P is there, P to Q to S was there, you will get a value called as Q to S. So this is modest tolerance, that's what you have seen. These rules are implicit, see here. P to Q was given and P was given, the inference is a Q. The same thing I have done. So P is here, P to Q to S was there, so the inference is Q to S. Q is here and Q to S is here. So Q was here and Q to S was there, the inference is yes. So whatever the inference that was given here is right. So what is that? The advantage that you have in NDS is having all the inference rules from 1 to 9. You can use any of the rules to prove this. At the same time, there is no restriction on the number of operators that you use. You can use the operators. And other thing is, if you use Q one time, you can also use the Q in other time until unless you get the output. If you use this sentence one time, you can use that sentence as many times as you require until unless you get the output. So what is that we are trying to do is we are taking some statements and you are having some inference. You are just proving that the inference is right or wrong. So again, this is a very important question. Most of the time, this type of questions will be asked, and this question itself they are asking many times for various reasons. So what can be the outcome here? What can be the inference that you can get from here, and how it can be something like this? Very important question this is. See, you have three statements with two variables and I have one statement with one variable. So in general, there is no rule that I have to start with a negation of m. You can start with any of the variables. But since it is a unary variable, if I wish to start with negation of m, because m was involved here, I will take this 2. What will happen here is the negation of p, or m will be there, and you have already negation of m here. So what is that you get from here is you will get a negation of p here. So if you combine this with this, you will get a value called as q. Since q was there, you combine q to r with q, so you will get a value called as r. So r is the inference. You have an inference which is valid is called as r, and p r q is also a statement which was valid. So you can combine these two statements by using and. This is what the rule says. You have a statement called as p, you have another statement called as q. You can combine both of them by using and. So obviously, this here, what is that we do is we will combine this r with this statement that is already valid that was given here. So this inference is also valid. So most of the time when people try to attempt this artificial intelligence questions in the external exam, in general they will start with this inference mechanism. The reason is they see these problems will be given for 8 marks. and it will take at most 1 minute to solve this problem. Once the problem is right, obviously you'll get all the marks. So there is no chance, almost 90 to 95%, there is no chance that you will not get marks here, because it's a simple logic and simple strategy, whether it is NDS or axiomatic search. So this part also was done in the class, but again it was given for 8 marks, and this many number of conclusions were given. You need to identify which of the following inference this is valid, or this is valid, or this is valid. Among these three, how many are valid, how many are not valid, based on the data that was given here. So you can start anyway, like see, when two statements are combined here, you can take any of the statements. You can take either P or Q. You can start like that, because you have a rule like this. See here, two statements are combined with and, you can take P or you can also take Q. It depends. So here two statements are combined, so you can take P or Q. So if I take P and combine this with this P2, Q and P, so what is that I will get is, I will get a negation of Q and R. So how do you proceed here? Like, how can we get the value, how can we proceed to get some value here? So still, if I just wish to expand this part, this is negation of Q or negation of R. So what can we get from this? See, from this P and Q, you can also get this Q. Q and this, if you combine, what is that you will get is negation of R. So if you combine S to R and negation of R, because S to R, S implies R is negation of S, R, and you have a negation of R here. So obviously negation of S is a valid fact. So what you got is negation of S is a valid fact. Once negation of S is a valid fact, S is not a valid fact. Once negation of S is a valid fact, you can add any value in the terms of R. This is what your rule is. You have a statement, you can have other statement that can be added by using R. So obviously this is also true. So this is also very important problem pertaining to NDS, natural deduction system. Many times this problem was given. If you see the external examination paper, without this question, most of the time you will not find papers, because this is a very important question, which is valid, which is not valid. It's all logic, and it will happen less than 1 minute. So it's a simple question that was answered in the class again. So three statements are given, and surprisingly three different inferences are made, and you are asked to validate in among these three which is valid. So how can we start here? See, I have three statements. This statement is having three variables. This statement is having two variables. This statement is having one variable. So there is no rule that where I have to start, but since the number of variables are less, I can start here. So I will combine this statement with this statement. So what is A implies B is negation of A, VB, and you have a negation of B here. So negation of B will come here. So obviously this value is negation of A. And I can combine this negation of A with this one. So P and P to Q, the outcome is C and D. When you have C and D, you can take either C or D. This is what your rule says. You have P and Q here, so you can take either P or Q. This is how you have taken this. So as per the inferences are concerned, C is a valid inference. C is valid. So negation of C is not valid. And C and M is not there. M is not listed in any of these three statements. So C and M will not work. This is not a valid inference. What can be the valid inference is C or M can work. This is a valid inference. This statement is not valid and will not work, because if you wish to add, as per the rule says, if you wish to add, this can be done. See, I have a statement like this which is valid. What can I do with this statement is, you can add something called as R like this, which will not change the truth value of the statement. You cannot AND, so you need to use only this R operator. So the last part is very important. This example 5 and example 4 are many times I have seen, particularly in your external exams. Logic is simple and it's obvious that it is. So this is a simple question actually. So just we have only one statement with 3 variables, other statements are with 1 variable. So you need to just find out how we can start. I will just erase this part. So most of the problems that I have done today are discussed earlier in the classes. That is the reason I'm just going in that phase. So what is the variable that was common with unary variable? This is C and this is C. If you combine them, what is that you can get here is, if you just expand this part itself, you will understand A or B can come negation of BC, and from this you have something called as negation of C. So this 2 will go, and negation of A, and this you will get a value called as B. So B is a valid inference. When B is a valid inference, BVS is also valid, because you can add by using R, or BVSV, P can be valid. You can add any number of variables here. But interestingly, when we observe the trend in which the questions are asked, S is here. S was not located in any of the statements here. In the same way, we are talking about M here. M was not there in any of the 3 statements here. We are talking about R here, but R was there in the earlier statements. You need to be very careful when this type of things are asked. When you add something called as R, when R was there in the statements, you should be more careful. If R is not there, there is no problem. So all these are very important. So this is what your 7th example says. So can somebody just unmute yourself and start where exactly we have to start? It is surprising today nobody is speaking. I could see 32 people are there, and All these are simple stuff that we are discussing today. Still, so many are not. So if you see all these four statements, all the four statements are with two variables. So seventh example is very, very important in the context of your external exams. Even this was taken from your exercise of your textbook called Rich and Knight. So if you combine P and Q with and, so what is that you can do is you can take either negation of P or you can take Q also, because it is combined with and. For simplification, you can take like that. So if you take negation of P and combine this with this, you will get negation of R, V, negation of have a P here, so obviously this negation will come, but negation will come at a later time. So this negation P is coming from here, this P is coming from this actual rule. So this 2 will go, and you can have negation of R here. So from negation, since negation of R is here, if you combine both of them, you will get something called as S. So if you combine these two, you will get something called as T. So you need to understand T is a valid inference. So when T is a valid inference, if T is a valid inference, then you can R any of this inference with this. This is also valid. Can somebody just unmute yourself and tell whether this procedure that I have adopted is right or wrong? So most people are reluctant to talk. Anyway, what is that I have done in this class is, particularly this class was asked to revise in particularly the problems that we have done in the earlier classes. So as far as that instruction is concerned, I have taken some problems in natural direction system. So natural direction system, I said, is a system which allows all the symbols, which is a flexible system, and it will also is governed by these 9 rules. Mostly we will use the 7 rules because the 8th and 9 rules are the part of the 7. So obviously we will use the 7 rules to infer something. Every time when you move from one state to other state to make a valid fact or inference, so these rules are used. So likewise, you have another system that was discussed for for the last 3 days. Like we have something called as axiomatic system. So in this axiomatic system, many symbols are not allowed. You cannot have or, you cannot have and, you cannot have bijection. Only symbol that is allowed is implication, and this is a universal symbol, so not can be applied, because all this, whenever not is applied, it's unary. So obviously this is what the story is. So but you can only apply this inference rule called as a modus ponens. Whenever P to Q was there and you have something called as P, the inference can be Q. Nothing more than that. So if you remember, in the morning we have a class where the next type of inference system was taken, that we call it as a resolution mechanism, where in resolution mechanism I take a statement, convert that statement into predicate logic. From predicate logic we try to infer. So Rama is a boy. If I have a statement like some statement was given to me as something called as Rama was a boy. So in general, what is that we do is we try to convert this statement into first order logic. boy of Rama. Rama is eating cabbage. So eat of Rama, something called as cabbage or something. This is very important. Rama is eating cabbage. So you represent this. Rama eats cabbage. So this is the second method. Like whenever you have a statement, that statement has to be represented in first order logic like this. Then from these statements we try to infer. The third method, that's what I said, is Rama is sleeping, Rama is running. So based on the semantics of this statement, we try to infer. Three different types are there. You infer based on the symbols that we have seen. In the morning, we have started a mechanism called as resolution mechanism, where I have a statement. This statement will have a first order logic statement. From this, we try to infer. The third one is Rama is a boy. I need to understand the meaning of the statement, and based on the related statements, based on the context, based on the meaning, based on the earlier statement and the succeeding statement, we need to understand the meaning. When your system reads a set of statements, what is that it will do is it will understand the meaning based on the dictionary. Then it will understand and relates the meaning of the statement in the context of the narration that is happening. The third thing is what was before the statement and what was after the statement. Four things it will consider: the meaning, the context, the predecessor and the successor. Based on these four, it will try to understand what exactly is the meaning of the statement, and based on the meaning of the set of statements it try to infer. So whatever we do in the morning is called as a resolution mechanism. Rama is running fastly. Rama is running fastly. So I say a run is a verb. What is that? Who is doing is Rama is doing, and he is doing something called as running, and he is doing some fastly or fast or something. So when you try to design this first order logic, then the problem is whenever you have a run outside, like I have a set of statements where run has come again, then that run should have only two parameters, Rama and fastly, like x and y, something was x. See, x is running fastly. Again, this run should have only two parameters. It cannot have three parameters. So you need to understand here, Rama was eating cabbage. Some person like Marcus is also eating a cabbage. The x value will change, but the number of parameters will not change. Rama was killed by somebody. Rama was, so killed will be there. You have something called as Rama. Rama was killed by somebody. We say that is y. This y will have an existential quantifier. So what is that we do is we are just generalize the things in the terms of specifiers, like it is a, whether it is a universal specifier or existential specifier. Based on that, we try to represent the knowledge. And the interesting fact that you need to understand in the inference mechanisms is when people try to convert, see which of the following inference is valid is a statement. This was written in a language called as English. The same sentence you can write in Chinese or any other language, but all these statements with the same meaning should have the same representation. When all the statements will have the same representation, obviously the inference mechanism is faster. So that is the reason when there is a crime that was happened, that's what I said in the earlier class also, when there is a crime that has happened somewhere, the confessions that these accused are recorded and they are given into a system, and system is getting processed. System is processing that audio and video. Based on that, system will ask many queries. Where are the irregularities? where it needs more data to answer, or where it needs more data to infer. So all these are very important. So whatever we discuss in the class is very simple aspects in the terms of how do you get the outputs, how do you design a system, that's what we will discuss. But the implementation part, you need to read a textbook and come back. So for the implementation part, you need some ambience, interest towards the subject, and you need to take more time, at least 5 to 10 minutes, or at least 2 to 20 to 30 minutes, so that you have a different expertise and some subject which is different from other people. So this part is very important. If you wish to do that part, you need to interact with the faculty. A lot of things will be there. You need to browse, you need to get assistance from various people. So obviously this all these things will help you uh, to have a different dimension of knowledge as far as AI is concerned. So I'm I most probably I will not take more time. I'm just stopping this recording.